Hey everybody, this is Larry. This is day 17 of the Leetcode Daily Challenge for January. Hope everyone's having a great day. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Count sorted vowels strings. So I usually solve and explain these problems live. So if it goes a little too slow for you, feel free to fast forward because I like to go over my thought process and not just the solution. So okay. So given the integer n, return the number of strings n that has a IOU and are lexicographically sorted. Okay. Number of strings and okay, so there are only 5 vowels and they're lexicographically sorted. That means that it only goes from A to E to I to O to U. Okay, so I mean this is not I mean, this is, to be honest, this is pretty straightforward for me in terms of problem solving. I think I'm just trying to figure out what's the best way to explain it for this video, to be honest. But okay, one way to think about it is, okay, I think so there is a dynamic programming solution, and then we can kind of think about it in a number of ways. You can actually do this recursively, and but for these kind of last character ones, I actually like to do it bottoms up. So if you are having trouble with the recurrence, definitely let me know, because I think top down recursive way of solving it is it's more intuitive for me. But this for this one, it might be. So basically, what we want to keep track is just the previous state and the current state. So the previous state is equal to, say, let's see. Yeah, so 1 times 5. And what this means, and then current is equal to, they just do 0 times 5 for now. And basically these are the two states, right? So what are these states? I didn't go over yet, so you should, either or you haven't, but the states are that, okay, so, and you could actually make this an n by n. Yeah, okay. For n is equal to 50. Okay, fine. Let's actually create a 50 by 50 matrix, or n by 5 matrix. Sorry. So yeah. So let's just do this is equal to 0 times 5 for range of n. Is that right? Yeah. And then for this dp, the states are dp sub I j is equal to let's see, the number of ways to count with I numbers, 9 I prefix, and the last character is j, right? So the key thing to note here for this problem is that it has to be, they call it lexicographically sorted, but it's just increasing, right? Monotonically increasing. And I think the other thing I would say, just to make this a little bit simpler, is that instead of using AEIOU, which is 5 character or 5 alphabet of 5, we can just use 5 numbers, which is 0, 1, 2, 3, 4, right? And then, because, and in that way, it makes it obvious that the quote-unquote lexicographically sorted order is just an increasing order. And now we can actually change this from last character, last number is j. And that's pretty much how I would go about it. And then now we just have to kind of, well, first let's go over the base case. What's the base case, right? Well, it goes to 1. So for j in range of 5, so basically now we're just creating, there's one way to n. Maybe this should be +1 actually. So then, in this case, we can just do. Yeah, let's do it that way. Right, and then now, for I is in range of n plus 1, starting from 1. For j is in range from 0 to 5, and then what are the states, right? Oh, so we already have the states. Now what are the transitions, right? The transitions are just I sub j. We added to, so there's a path, or we maybe not path. I mean, it is a path because it's dynamic programming. I like to explain dynamic programming with paths, but this is basically saying, okay, equal, right? Okay. So basically, what this is saying is that this current new last character is J, right? And what can we add? Like how many strings are there to add to from the previous states, right? And what I mean by that is that, okay, so for example, one way to think about it is, let's say you have 0, 0, 0, 0. Now we want to, for each of these zeros, we want to add 0, 1, 2, 3, 4, 5, right? And what this is saying is that, okay, the number of the only thing that affects whether we can add the last number to the previous number is the previous last number, right? And from that, we're able to do this count because there is a path from J or from K to J if K is smaller than J, which in this case we do a for loop that makes sure that that's the case, or equal to, and that's pretty much it. And then we can do something like return sum of dp's dp sub n. Yeah, what is it? 233 50. Do we have to mod anything? Does this get too big? No. Okay. Yeah, looks good. Is there 0? No. Okay, so I'm relatively confident, but yeah. So basically, I call this the digit DP because basically you're looking only at the last digit, and also a little bit of a prefix DP because it only matters what the prefix is and then the last digit of that prefix. And yeah, so what is the complexity of this? As we talk about, this these two loops are, you could say, I mean, it depends on how you want, if you want to consider these variables or not. But in this case, we'll use alphabet or alpha for alphabet. So alpha, which in this case, it's going to be alpha is equal to 5. So it's a constant, but I like to go over just in case you want to add more things. If you want to add more characters or numbers, that's okay. In this case, this is just alpha times n, right? Because there's a loop for n, a loop for alpha, and another second loop for alpha. Yeah, and in terms of space, it's going to be O of alpha times n for the same reason. We just look at here, and there's an alpha, and this is n, right? And again, of course, you could say that in this case, alpha is a constant, and then you could factor it out if you like, that's fine. One thing that I would say is that actually, and that's what I was going to do, but I think maybe that's too advanced for me to do on the tutorial, is that, and I'll have a link below, or you could ask about it, about my dynamic programming progression video, and it talks about a safe space, and in this case, the space is, as we said, O of alpha times n, but you can actually reduce this to O of alpha, so, which is constant time if you want to call it that. So yeah, constant space if you want to call it that, with O of n, with the same complexity of O of alpha times n. Cool. So this is a dynamic programming, like I said, is a digit dynamic programming. Get familiar with it. Basically, the counting is that the state is just the number of ways to count with the I prefix, where the last number is j, and and then you kind of build off that because for the I plus 1 prefix, you add a new character, and the only way you can add the character is if the new character, in this case I use k, is, I guess I mixed them up in this notation, but you could add it to the previous prefix if the previous character is smaller, and that's basically how this recurrence comes up. Cool. And yeah, and you could of course do this recursively as well with top down and memorization. That's all I have for this problem. It's been a long day, so maybe I don't know how. Let me know what you think about my explanation. I think it could be a little bit better, to be honest. But I think this is a good practice for digit DP. So definitely practice it, play around with it. And I would rate this a little bit on the easier side of digit DP. Digit DP is not easy, but of the digit DPs, this is probably one to kind of get practice on and really make sure that you understand what the indexes do and what are the states and why you can add to each other. Yeah, that's all I have for this problem. That's all I have for today. Man, I am sleepy, but hope everyone had a good time, and I will see y'all tomorrow. Bye bye.